Hello everyone. So we're going to go ahead and start by covering something we learned at the beginning of the year, and it's something that you're really going to need to remember when it comes to your math next year and the year after, because this is something that you're going to see over and over again. So the first thing is combining our like terms, right? Combining like terms to solve our equations. Our lesson question is, how can you solve linear equations by combining like terms? First thing is, our lesson goal is to identify these like terms, then to combine our like terms, and use the properties of equality to solve linear equations. So these are some words that we should know. We didn't really go into them. There's a couple of them that we did. For example, this guy right here. But the other ones, we have been using them, but I never gave the formal names. So it is the addition property of equality, the property stating that adding the same quantity to both sides of an equation does not change the solution set. You know, we've done that a whole bunch. So the next one is the division property of equality, the property stating that dividing both sides of an equation by the same non-zero, remember that if you can't divide anything by 0, it does not work. So the same non-zero number does not change the equation. The inverse operations are operations that undo each other, such as addition and subtraction or multiplication and division, right? These are our opposites. I always tell you, what's the opposite of addition? What's the opposite of multiplication? Those are the inverse operations. Multiplication property of equality, it's the property stating that multiplying both, remember that whatever you do to one side of the equal sign, you do to the other, stating that multiplying both sides of an equation by the same value does not change the equation. And the subtraction property of equality is the property stating that subtracting the same quantity from both sides of an equation does not change the equation. So these are all the rules that we use, and it's why, you know, we can add and subtract things from either side, and we can, you know, not have an issue when finding the actual answer at the end. Okay, so now we're going to do some examples. So the inverse operations of and properties of equality. Inverse operations are operations that undo each other, addition and subtraction. So in this first example, right, we have the addition property of equality. So it's going to be A plus C is going to equal to B plus C, right? So they have the example right over here. I have x minus 4.3 equals 0.55. So if I do the opposite and I add that 4.3, 4.3 plus negative is going to give me a 0 over here. But when I add it up over here, and I don't really like the way they line it up, because why? This 0 matches with this 4, and that 5 matches with that 3. So this 5 actually has a 0. So that's going to be a 5. 5 plus 3 is 8. And my 4 is going to stay the same. Okay? Now the subtraction property of equality is going to be the same thing. It's going to be A minus C is equal to B minus C. Okay? So you need to notice which letter stays and which one is going to be added to both sides. So in this example, right, they go ahead and they add that. That's going to be 0. Now this is over 1, meaning I have to change this 8 into having a denominator of 5. So to do that, I multiply the top and the bottom by 5. That's going to give me, what? 8 times 5 is 40 over 5. Now I'm going to subtract 40 minus 2. That's going to give me 38 over 5. Remember, this is my larger number, so I'm going to keep that positive sign. Okay? And you can leave it as this, or if you want to change it into a mixed number, right? The largest number that 5 multiplies by to get to close to 38 but doesn't pass is 7, right? That's 35. And 7 3/5. Okay? Again, you could have just left it as the improper fraction. So the next one, we have the rest of our properties of equality, right? Once again, I have my A, B, so that means that my C is going to go right over there. And we're going to see right now, solve x divided by 3 equals 6, or x over 3. Remember, I told you that the fraction is just the division, right? And actually, you can see here, let me use a different color, right? Here's my division sign. And we can see how this kind of looks like our division sign, right? It's a fraction. So I'm going to go ahead and I multiply both sides by 3. That's going to get rid of my fraction, right? It's a little easier to see as the fraction form than as, just the little symbol. So when I do that, again, it cancels it out, and 3 times 6 is 18. Now again, I'm going to do A divided by C for the division property. So remember that C cannot equal 0. Okay, so I divide both sides by 5.5, right? Because the opposite of multiplication is division. And I actually end up with 6, right? You can use a calculator for that one. I don't expect you guys to do that one in your heads, but it would be 6. Okay, so the next, we're going to combine like terms to solve an equation. So this should match what we were doing earlier today on Thursday, on Monday's Zoom meeting. So first step is identify and combine your like terms. Remember, I told you that was step 1. Combine your like terms, right? So the first thing is I'm going to go ahead and look at these. Both of them have x's. Both can be combined to 11x, right? And I'm going to write that in already. Now my second step is use the properties of equality and inverse operations to solve the equation. So now I have 11x. I kind of give it away, right? I'm going to end up dividing by 11. And a 66 divided by 11 is just 6, right? Now the third step, the most important step, check your answer, right? 5 times 11 plus 6 times 6. So, it is not 11, it is 5 times 6. Remember, your x equals 6. So 5 times 6 is 30. 6 times 6 is 36. 36 plus 30. And we can write it out on the side so you guys get it a little bit more concrete. 6 plus 0 is 6, and 3 plus 3 is 6 as well. Okay? Next one. Combining like terms to solve equations. Again, writing and solving an equation. So this is when we have our word problems, right? So remember what I told you. The first thing you want to do in a word problem is you're going to go and make note of all the numbers. So Mrs. Garner needs to arrange 28 desks into rows on each side of her classroom with an aisle in the middle. There is room for 4 rows on the left, but only 3 rows on the right. How many desks should be in each row? Right? And I'm actually going to highlight my question in a different color. How many desks should be in each row on the right? Okay? So the first thing is to write the equation. So x is equal to the number of desks in each row. Now, she has only 3 rows on the right, 4 rows, but we don't know how many desks in that 4, right? Always look, if you have a 3x here, right? Well, there's my 3. What number matches in that same sentence? It's going to be 4, right? That's going to equal to the total of desks, which is 28. Now, identify and combine like terms. So I'm going to add my 2 x's, right? Here's an x, here's an x. So I combine 4 plus 3, which gives me 7x. Now use the property of equality and inverse operations to solve the equation. So if this is a multiplication, the opposite is going to be the division, so I'm going to divide by 7. This is going to cancel out because it'll give me 1. And then I'm left with 28 divided by 7, which is 4, right? And now it is time to check my answer. So 4 times 4 is 16. 3 times 4 is 12. 16 plus 12. And that's going to give me 28. Okay, so there should be 4 desks in each row on the right. Okay? Let me double check. Yeah. So, next one. We have equations, algebra tiles, interactive. So this is another way you could see this setup, right? They're giving us the word problems, they're giving us the basic, here's your equation and solve for it. Now they're telling us model using these algebra tiles. So it's a little funny, right? So model the equation using algebra tiles. It is 4x minus 3 equals 5. So we have our 4 mystery numbers. Let me try a different color. We have our 4 mystery numbers, right? This is my 4x. There are 4 of them here. Here are my negatives, which there are 3. And here are all my positives. And I count them out, 5. So there's my 4x minus 3 equals 5. They're just using blocks to symbolize it, okay? So the second is use the addition property of equality. Drag 3 orange squares to each side to add 3 to both sides of the equation. Okay, so that means I need to draw. Right, I want to cancel out this 3. Let me see if I can get an orange. Here we go. I'm going to draw 3 orange blocks over here. And 3 orange blocks over here. And I'm going to put that plus sign so I know that they're positives. Right? And that's going to actually cancel out these over here with these over here. It's a little bit chaotic. But now my new number over here becomes what? 5, 6, 7, 8. Okay? So you can see here they did it written out. It's a little bit easier, I think, it's for me. But, you know, if you guys like the tiles better, by all means, please go ahead and use that. So we have our plus 3, 5 plus 3 is going to still be 8. Now I'm going to divide both groups by 4. So that means that of my 8, right, I'm going to, let's take the pink. It's going to be one group of 4. Here's my other group of 4. That leaves me with 2 groups, right? So if I were to plug it in here, 8 divided by 4, that's 2. Okay, so it's the same thing, just again, a little bit funny to see, but it's showing you that for every one of these x's, you have 2 plus, okay? So I just wanted you guys to see all the different ways they can show you these kinds of examples. So the next one, combine like terms. Now we're going to go ahead and do two-step equations, right? We did two-step equations. They have, again, 2 steps, remember? So the first one, you're going to undo addition or subtraction to isolate the variable term, okay? So here's my example. 3.25x minus 4 equals 15.5. So my first step is to add that 4 to both sides, get rid of it. That's going to give me 19.5, right? Remember, this is really 0.0, so that lines up with that, and there's nothing to line up with that 1. So it becomes 19.5. Now, undo your multiplication or division to isolate the variable. So in this case, I have my 3.25x, that's multiplication, so I'm going to end up dividing, right? Once I do that, plug it into your calculator, it's going to give me 6. Okay, now I check my answer. 3.25 times 6 is going to be 19.5 minus 4. So if I were to write it out, 19.5 minus 4, now remember that's 4.0. Nothing happens with that 5. 9 minus 4 is going to be 5. And it's going to check out, right? And it's going to equal 15.5. Okay? Now we're going to using an equation to solve a word problem. So once again, it's another word problem. Let me get the highlighter ready. Morgan wants to buy a new smartphone that costs $172. She has already saved $70. She makes $8.50 per hour babysitting. How many hours will Morgan have to babysit to earn the rest of the money? So again, that's my question. So I'm looking for how many hours she'll have to work. Okay? So H is going to be the number of hours. Now, I want to point out this 70 is here because she already saved it, right? You'll see ones that say so-and-so already saved this, or they had a birthday and grandma gave them $100, something like that, right? That's this case. I already have $70. It's not going to change depending on how many hours I babysit, okay? So in this box is going to be my 850 and then the letter H for hour, right? And it equals 172. Now it equals 172 because that's how much that phone is and that's how much she needs to save up. So the first step was write the equation. I'm going to go ahead and put a check. Now my second step is undo addition or subtraction. Now remember, I want to move my like terms, so if there's no H, I only have one with an H, and the other two don't. So I want my two that have no H's to be on the same side of the equal. So I'm going to do the opposite of the sign. This operation is a plus, so I'm going to do the negative sign. And I'm going to do the subtraction. 172 minus 1 minus 70 is going to give me 102 and 850. All right, so now I can check that one off. Now undo the multiplication or division. So again, this is multiplication, so I'm going to divide both sides by 850, right? That's my check there. And if I put that into my calculator, it's going to give me 12. Okay, now I need to check, right? I'm going to plug it in and check. So 850 times 12 plus 70 should give me 172. So $8.50 times 12 will equal 102 plus 70, 102, so I can check off that last step. Okay? Again, it's the same routine over and over. Once you guys get the steps, I promise you this will be a breeze, right? You just do the same thing, okay? Morgan will have to work 12 hours to save up for her new smartphone, okay? Now, how to solve multi-step equations. So this is going to be multi, so more than one, right? Solve the equation for x. Identify and combine our like terms. So I'm going to circle all of my x's, and I'm going to circle all of my regular numbers, right? So I'm going to combine. Now, I have negative 3 plus 6, which is really the same as saying 6 minus 3, right? So if I were to do that, it's going to be 3x. 3x plus 4 equals 13. Negative 4, and then I need to do undo the addition or subtraction to isolate the variable, right? So I want to get rid of this 4. It does not belong. It doesn't have an x. It needs to combine with its other purple number. So I'm going to do the subtraction again, right? I'm going to do the opposite of whatever this sign is. I'm going to subtract. So 13 minus 4 is going to equal to 9, okay? Now once I do that, I need to do step 3, undo the multiplication or division to isolate the variable. When I do that, I'm going to, again, divide by 3. Because this is a multiplication, my opposite is the division. So I divide by 3. That's going to give me 9 divided by 3 is 3. Okay? Now the last step is to check your answer. Negative 3 times 3, that's going to give me 9, but I have to remember there's only one negative. Remember, you need 2 negatives to equal a positive. So if there's only one, it's going to stay a negative. So negative 9 plus 18 plus 4 equals 13. Now I'm going to check. So I'm going to do 18 minus 9. That's going to give me 9. 9 plus 4 is going to give me 13. So 13 still equals 13. It's the same steps. Doesn't matter how many times you have to go through it. It's the same routine. You're going to use those properties. You're going to use all that information, okay? So how can we use linear equations combining like terms? So our answer should be after simplifying each side by identifying and combining we can use the properties of equality and inverse operations to finish solving for the variable. Okay? Now, if you have any questions,